Hi everybody, welcome to section 1.2 in trigonometry. We study about triangles. So a triangle means three. So a triangle is a polygon in the plane with three vertices and three sides. By normal convention, it doesn't matter where we label A, B, C, but if we use the capital letter clockwise or counterclockwise, doesn't matter. But opposite to the angle A is the sine little a. Opposite to angles B is the sine little b. And same thing for little c, sine little c, opposite to angle C. If we want to distinguish the big C and the little c, later on we have a little hook like that. Anyway, now basic triangle facts. So the sum of three angles is 180 degrees. So all angles add up to 180 degrees. And by the way, in the high school geometry, usually we say the measure of angle A. That was unnecessary. I just say angle A, the measure of angle A, B, C, which is a letter. That'll be enough. In terms of size, we have a triangle inequality, meaning that the sum of the length of any two sides is greater than the third one. So this makes sense. Let's say if we have one side, this is way too long, and the other two sides, that is not long enough. If these two sides do not add up more than the third side, those sides will never touch to form a triangle. So they have to be long enough so that the length of the sum of the length of two of them must be greater than the third side. Right, this will come in handy a lot later down the road. Angle side properties. Larger angle have larger opposite side. So bigger angle face bigger side. So if little a, sine A is longer than sine B, then angle A is bigger than angle B. If angle A is bigger than angle B, then the sine A is longer than sine B. And then the area of a triangle given by 1/2 base times height. And we do not use A for the area of the triangle because that's confusing with the angles. So we use K. Right, let's look at the first example. For the angles in the triangle here. So we have a properties that those three angles add up to 300. All the angles add up to 180 degrees. So we have 70 degrees plus 39 degrees plus x plus 26 degrees plus x equal to 180 degrees. We just solve for x here. This will be easy. So 70 degrees, 39, 26. I'm sorry, where's the x? 26 and x. So all of those add up to 70 plus 39 plus 26, 135 degrees. Plus 2x equal to 180 degrees. Subtract 135. It's 45 divided by 2. So x is equal to 22.5. Right, so that's good to know, but we did not ask for x. We asked to find the angles of this. So in this triangle we have x is equal to 22.5. So 39 plus x So 39 degrees plus x. (61.5 degrees). And then 26 degrees plus x. X is 22. I just going to say 26 plus 22.5. That is 48.5 degrees. So in this triangle we have 48.5, 61.5, and of course 70 degrees. So in that triangle we have those three angles. Okay, 70 plus 61.5 plus 48.5 is 180 degrees. So that's good. Right. Classify triangle. Triangle can be classified by angles or by size. In terms of angles, we have acute triangle, meaning all angles are acute. The right triangle, when one angle is right angle, and obtuse, where one angle is obtuse. Because they add up to 180, so they cannot have more than two right angle. Cannot have two or more right angle. Same thing for obtuse. Right. So classify by angles. Classify by size. We have equilateral triangle. All three angles have measure of 60 degrees. All three sides are equal. Isosceles triangle, where two sides are equal or two angles are equal. And then the scalene triangle, all three sides are different length. Different lengths. Right. So that's how we classify triangle. Acute, right, obtuse. If we want to classify based on angle. Based on side, we have equilateral triangle. All three sides are equal. Isosceles, two sides are equal. And scalene, all of them have different sides. Right. Right triangle. In a right triangle, we have the side opposite to the right angle is called the hypotenuse. And that is opposite to the right angle. The other two sides are legs of the triangle. And in Pythagorean theorem, we have in the right triangle, the square of hypotenuse equal to the sum of the square of the length of the legs. So C is, this case is hypotenuse. That is opposite to the right angle. And that is the longest side. Square is equal to the sum of the square of the other two sides. The converse of Pythagorean theorem, if we have a square plus b square equal to c square, then the triangle ABC is a right triangle at, this is capital C, is angle C, because I said angle C is opposite to sine C, and since C is the longest side, angle C is the biggest angle. Right, let's prove. Right, this is proved by picture. We have a square inside a bigger square. This, all those triangles are equal essentially. So we have, this is A, this is B, and this is C. Same thing, A, B, and C. A, B, and C. A, B, and C. Right, so we have all of those sides. Now let's find the area of the big square. So we have, it's also a square of, sorry, yeah, so the shorter side is A, the bigger side is B, the hypotenuse is C. So this is A, B, A, B, A, B, A, B, sorry. So on the big square, we have the size of AB, so the area of that is equal to A plus B square, right? The size square, so A plus B square equal A plus B times A plus B multiplied out A square plus AB plus another AB plus B square, so A square plus 2AB B square. Right, so that is one way to evaluate that. Another way to find the area of the square, of the big square, is equal to 4 times the area of the area of the triangle. And then plus the area of the square here, of the little square. Right. The area of a triangle is 1/2 base A, right, for triangle. 1/2 base times height, 1/2 A times B, and the square side C will be C square. So this gives us 4 and 1/2. That cancel out, we have 2AB plus C square. Now, the area of the big square can be given by 2AB plus C square, or A square plus 2AB plus B square. So those two are equal. So just make them equal. Because they are both of them equal to the area of the big square, so we make them equal and cancel 2AB on both sides. So A square plus B square equal to C square. So that is a simple proof. There's another proof of this. So we can write, this is A, B and B. Sorry, actually that was wrong. I thought I changed this in the note, but I forgot. But anyway, so the picture is supposed to look like this. Sorry, I thought I fix that on the note, but apparently I forgot. Right, so this should be A, B, A, B, and then C and C. So apparently the picture actually we have should be half of this. Yeah, if we only consider half of this, and that's what we have here. Sorry, that should be like this. Half of that. Right, so the proof will be similar to this, but instead of using the whole thing, we cut everything in half. By the way, this proof is proved by the US President Andrew Garfield. So of course I'm just gonna throw it out there, but the proof is exactly kind of like this, but we write everything in terms half of this. So I have half of the square, half of the big square, and then so on. So sorry about the graph. It's supposed to look like this. Right, so as example, moving on. So as an example here, a 26-foot ladder placed 10 feet from a house reached the top of the chimney of the house. How high is top of the chimney to the ground? So just draw the picture real quick. Let's say it. So that's the chimney. Right. Like that. That is the house, and the ladder is 20 feet. And place 10 feet from the house, and we assume that the house built straight up. So this is 10 feet away from it. The question is, how high is the top of the chimney to the ground? So we asked to find this length. And that is x. Right. We assume that the chimney is straight up, so that's 90 degrees. So it's easy enough. Pythagorean theorem: opposite to the right angle is the hypotenuse, is the longest side, so that will stand by itself. That's square, 26 square. X square plus 100, 26 square so it's 676, subtract 100, 576. I'll get back to x. We take the square root. That should be 24. Square root of 576. Right, 24. Yeah. So from the chimney to the bottom, to the ground is 24 feet. Right. Next, solve for x in this triangle. So once again, this is a right triangle, so we can use the Pythagorean theorem. X squared plus 3x plus 3 for x minus 3. So x squared and 3x plus 3 squared. Again, this is not 9, x squared plus 9. Just multiply it out. That gives us 9x squared, 9x, and another 9x, so that's 18x. plus 9. Right, 4 times 4, 16x square minus 12x minus 12x minus 24x plus 9. Right, move everything on one side and solve for x. So this is 10x squared plus 18x plus 9. 16x squared minus 24x plus 9. You can subtract 9 on both sides. Move everything on one side. That gives us negative 6x squared, 24 and 18, that's 32. I mean 42. Right, we can factor out an x. How about factor out negative 6x? That gives us 1x left, minus 7. So we have 6x equal to 0, so x equal to 0. Or x minus 7 equal to 0, so x equal to 7. Of course, the measure of an angle cannot be 0, so it have to be 7. So if we put it back, this side is 7, because x is 7. 4 times 7 is 28, minus 3 is 25. And then 3 times 7 is 21, plus 3 is 24. So we have 7, 24, and 25. How about 7 square plus 24 square and 25 square? Yes, so, and this is correct. So it's time to check the answer. Right. So x is 7. Alright, on the right triangle, there's some special right triangle. First one is 45, 45, and 90 degrees. This is called isosceles, because those are the similar. They have the same size, so isosceles right triangle. Right, this is also called the isosceles right triangle. Alright, so we have, let's call that x, x, and 1. So what is, how do we solve for x? So once again, Pythagorean theorem, x squared plus x squared equal to 1 square. So we have 2x squared equal to 1. So that gives us x squared equal to 1/2. If we solve for x, take the square root on both sides. Square root of 1/2. Now, square of 1/2 you can write square root of the top or square root of the bottom, or just 1 over square root of 2. For me, that's perfectly fine. However, in algebra, sometimes they don't want to put the square root at the bottom. So in that case, we have to multiply by square root of 2, top and bottom, multiply by the same thing. So we have 2 at the bottom instead. So either 1 over square root of 2 or square root of 2 over 2. Those are the same values. But yeah, so we can use either of those numbers. Right, the conclusion. Of course, we can say x is 1 over square root of 2 or square root of 2 over 2, and the hypotenuse is 1. So the conclusion, I think, to write like this is a little bit better. So opposite to 45 degree angle 45-degree angle and 90-degree. The sine will be proportional as square root of 2 over 2, square root of 2 over 2, and 1. So this is red. Opposite to 45, 45, and 90 degrees angle are the length of square root 2 over 2, square root 2 over 2, and 1. Right, so that's the first special right triangle. The second one is called the half equilateral triangle. I actually have this here. So the reason of that is if we have the other half, this is 1/2, this is also 1/2. Those together is 1, and the hypotenuse is 1. So we have 1, 1, and 1. So that is an equilateral triangle. We just cut that in half. So that's why it is called half equilateral triangle. But what we focus now is just half of it. Now we solve for x. So also a right triangle, first and foremost. Now, in this right triangle, we have 1 over 2 square plus x square equal to 1 square. Right, 1/2 square is 1 over 4 plus x square equal to 1. Now, if we multiply everything by 4, that gives us 1 plus x square equal to 4. Move the 4 over, x square equal to 3. Take the square root on both sides. X equal to this will be 4x squared. Right? Multiply everything by 4. So 4x squared equal to 3. So x squared is equal to 3 over 4. And if we want to solve for x, we just take the square root on both sides. Square root of 3 over 4. So square root of 3, square root of 4. So this is square root of 3 over 2. Right. So the conclusion here is opposite to 30 degrees, 60 degree, and 90 degree angle are the size of length 1/2, square 3 over 2, and 1. So those are the two special right triangles. Let's look at some example. The shadow of a flagpole is 20 foot long. 20 feet. When the angle between the shadow end and the top of the flagpole is 60 degrees. So first we have the flagpole. Once again, we assume that it is perfectly vertical. So there's a flagpole. The shadow is 20 feet, and the angle between the end of the shadow end. So assume that it will cast a shadow and it says from the end of the shadow here, angle between the shadow end and the top of the flagpole, so we talk about this angle, is 60 degrees. 60 degree. 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 60 degree And we know the shadow, the length of the shadow is 20 feet. How tall is the flagpole? So we have to find this length. Right. So, by the way, because we assume that the flagpole is perfectly vertical, so that is 90 degrees and that is 30 degrees. So we have 30, 60, and 90 degrees. So 30, 60, and 90 degrees triangle. Opposite to 30 degrees is 20 feet. All right. And opposite to 60 degrees is x. And we don't care about 90 degrees. But according to the theorem we have earlier, for two special right triangles, 30, 60, to 90 degrees angle have the ratio of 1/2 and square root of 3/2 and 1. So every 30, 60 degree, 30, 60, and 90 degree triangle, we have this ratio. So we have 20 is to x as the same as 1/2 is to square root of 3/2. So we just make the ratio 20 over 1/2 is equal to x over square root of 3/2. Right. Divide by fraction is multiply reciprocal. Right. Or just do cross multiply. So cross multiply. So take this 20 times square root of 3/2 equal to 1/2 times x. So 20 and 2 cancel out. We have 10 square root of 3 equal to 1/2 x. Just need to multiply 2 on both sides. 2 and 1/2 cancel. So we have x equal to 20 square root of 3. And it's going to be feet. So the length of x is 20 square root of 3 feet. Right. Simple enough, right? Next, find the distance between the tops of the two trees, 47 feet and 39 feet height. Find the horizontal distance between the trees. Right. Let's see, we have two trees. One of them is 40 feet. The other one is 39 feet. So and the other one is 39 feet. Actually, this scale is way off. Let's say it should be here. Okay. One of them is 47 and 39. So the distance between the top of the tree is 17 feet. So this distance is 17 feet. Find the horizontal distance between the tree. So we ask to find this horizontal distance. Of course, that horizontal distance is the same as this distance. And the size here, if the difference of the height of the trees, One of them is 47, the other one 39. So this is going to be 8 feet. So that is 8 feet, the distance of the height of the two trees. So out of that, we have a right triangle. And because right triangle, the problem with size, so that's going to be Pythagorean theorem. So we have x squared plus 8 squared equal to 17 squared. So x squared plus 64, I think 324, or 289, sorry. $289. Subtract 64. 225. Take square root on both sides, x equal to 15. By the way, when we take the square root on both sides to solve the equation, that should be plus or minus. The reason I not consider the plus or minus here because we solve for the length, and the length cannot be negative, so I just thrown away the negative signs. Right, next, congruence and similar triangle. So congruent meaning, loosely speaking, that means equal. Meaning that they have the same size. I mean, that kind of confusing. So meaning that the corresponding sides are equal and the corresponding angles are equal. The congruent meaning equal. The reason we don't use the word equal because congruent meaning that the shape is the same. So the measure of the angles are equal and the length of the sides are equal. So one of them is the length, one of them is the size, one of them is the measure of the angle. But all of them are said could be congruent. Right. So the criteria for congruent triangle, there will be two of them. We have a side, an angle between them, and the side. So a side, angle, and the side. When we have three of them, two sides and an angle in between. If there's corresponding and equal, then the triangles are equal. Or we say the triangles are congruent. Two angles and the side in between, or on three sides. Those are criteria of congruent triangles, meaning the triangle have the same corresponding sides are the same and corresponding angle are the same. Right. Next we have similar triangles. Similar triangle have the corresponding angles are equal. So this is the backbone of trigonometry is based on the similar triangle. So similar triangle only have the corresponding angles are equal. Consequently, the corresponding sides are proportional. Right. And the theorem says, even though the definition requires all three angles of this triangle equal to three angles of the other triangle, but in that we only need two. In fact, we only need two of them. All right. So once again, the corresponding angles are congruent and the corresponding sides are proportional. Right. So let's look at first example. Assume that there's some similar triangle here. If I want to specify that they are similar, all I need to do is marking the same. This equal to that angle, and this angle equal to this angle, and that's all we need. Two pairs of corresponding angles are equal. Those are equal. Those are equal. That's it. We don't need the third one because they add up to 180. Knowing two of them, we have the last one. Right. Now we focus on the sides though. Focus on x and y. Now on this two similar triangle, we have the ratio of this side over y which is the angle, which is the side between the two angles, equal to 6 over 12 and equal to x over 10. So, two similar triangles, the 4, 6 and x will be proportional to y, 12 and 10. Now we just solve for that easily. Cross multiply, we have 48 equal to, if we take this ratio and cross multiply, 48 equal to 6y. So y equal to 8 divided by 6 on both sides. Now if we take this ratio and cross multiply, we have 60 equal to 12x. So to solve for x, 60 divided by 12, so that is 5. So x is 5 and y is 8. So based on right triangle. Next, we have this graph, this picture. Right. Suppose DE and BC are parallel. Right. I didn't say what triangles are equal, what triangles are similar, but because they are parallel, remember from the first section, the corresponding angles are equal. So because DE and BC are parallel, this angle equal to this angle, and this angle equal to that angle. And then of course the angle A is a common angle. So what we have is the triangle A, D, and E. Now we have to write a very corresponding A, D, and E. So triangle, we just say triangle ADE and triangle. Now we have to write the corresponding angles. Angle A are common, and then with instead of D, we're going to go to B because D and B are equal. So instead of D, we can write B, and instead of E, we can write C. So angle A are equal to angle A here, angle D equal to angle B, and angle E is equal to angle C. So those two triangles are similar. And the reason we have to write corresponding like that, so the ratio will be easier to write. So we can say AD, the first two equal to over the first two on that side. First and last. First and last. The last two. Right. So because they are similar, we have these ratios. AD is 8. AB, A plus 4, 12. AE is 9. AC, 9 plus X. DE, Y. Over BC, 16. Right, so just work with ratio. So let's take this ratio, cross multiply, and then we solve for x. So 8 times 9 plus x equal to 12 times 9. 12 times 9 is 108. Yeah, cross multiply. Right, multiply the amount of 72 plus AX is 108. So AX 9 times 12 minus 72. AX equal to 36. So X is equal to 36 divided by 8. and we can convert to fraction if we want to, or cancel by 4, 9/2. So x equal to 9/2 or 4.5. Then next we will take the first and the last ratio and cross multiply. So 8 times 16, 128. 8 times 16, 128, equal to 12y. And we just divide by 12. And convert to fraction if we want to. 32/3. Right, so it's simple enough. Like I said, similar triangles is the backbone of trigonometry. But of course, we haven't gone to any of trigonometry yet. But that will be in the next section. Right, but I stop this section here. As always, thank you for watching.